All right, all right, all right. I think we are live. Hello, hello, everyone. Those who are joining us around the world. I am so excited for this code along. If you've seen one of these code alongs or webinars before, and I was a host, you see I have a different background today. Well, I am in the middle of moving apartments, so this is why you see quite a barren background today. Uh, but I wanted to say I'm so excited for this code along, and thank you all for joining us around the world, everyone is mentioning in the chat where they're joining us from. Do let us know where you're joining from. See here, Lorenzo from Argentina. Great to see you, Lorenzo. Uh, Vivian said, mentioning, hey, Reese, where can I find past webinars? You can find them on our resource center on www.datacamp.com/resources. Everyone, do let us know where you're joining from. I'd love to make sure that we highlight kind of your engagement, your interaction. And I think with that said, I'd love to introduce today's speaker and today's code along topic. It's widely known at this point that large language models hallucinate, as that is that they make up facts and content that is not necessarily rooted within reality. And a big solution to the hallucination problem for large language models lies within using vector databases and building retrieval augmented generation pipelines. So today we're going to be walking you through the art and science of building RAG pipelines. And note, to follow along, you need to have access to an OpenAI developer account. We're going to share instructions on how to do that within the chat, so make sure to check it out, as well as a Pinecone developer account. So make sure to check out as well how you can gain access to that. And if you're not able to follow along the code along itself, that's totally fine. We're going to send you the recording. So just make sure to follow along for, checking out how Roie will be following the workflow today, and then you'll be able to apply at your own leisure once you have the time. So with that said, I mentioned Roie. I'm going to introduce Roie today. Roie Schwaber-Cohen. He is a staff developer advocate at Pinecone, one of the biggest vector databases organizations today. Roie, it's great to see you.
Great to see you too. Thank you so much for having me.
Thank you so much for joining us. So Roie has nearly 2 decades of experience in software development and architecture with a specialization in big data and AI. His areas of interest include agents, interactions, and reasoning. A significant part of his work involves bridging the gap between Python and TypeScript and JavaScript worlds in the field of AI. And as a developer advocate, we have the pleasure of having him here where he can share his insights with the wider community. So with that, over to you, Roie.
Thank you so much. I really appreciate it. Thank you for the warm welcome. I'm glad to be here. So yeah, today we're going to be talking about RAG, and I'm going to be walking through an example showing basically how we stand up a RAG pipeline that is worthy of an enterprise setup. And I wanted to kind of like touch on one of the key capabilities that I think is perhaps the most important for this level of setup, an enterprise level of a RAG setup. So just to make sure, can we see the screen? Okay, perfect. Okay, so we'll do three things. First of all, I'll talk very quickly about RAG. I think that at this point, most people have already heard the concept, know sort of what the benefits are of RAG, and we'll kind of like look into like the architecture a little bit, and then I'll touch on some considerations that I think are important, mostly for enterprise companies, very briefly, and then of course we'll jump into the actual walkthrough. So, like again, like Adele said, RAG is that capability which helps with mitigating hallucinations in LLMs. The one thing to say about that is something that I've heard Andre Karpathy say multiple times, which is that LLMs don't hallucinate sometimes. In fact, they always hallucinate. All they do is hallucinate. And by that, I mean that there's basically the same level of assurance that an LLM, quote unquote, knows what it's talking about when we're interacting with it, and it doesn't vary over time, right? We don't have an indication of confidence given back from the LLM when we're running it kind of like straight out of the box, so to speak. Of course, there's ways to get probabilities of each particular token, but when we're talking about facts that the LLM spits back at us, we don't quite have a notion of confidence. And so the idea behind RAG, the fundamental idea here, is to anchor the LLM in a knowledge base that has been vetted and is trusted, and to make sure that whenever the LLM draws its responses, those come from that particular knowledge base that has been vetted. And the LLM itself acts as sort of a thin layer of a natural language interface that wraps around that knowledge. And the goal of RAG is basically to bridge the gap between the natural language domain where users live, where our queries live, the knowledge that is locked in our documents, and to basically allow those to flow back to the user with some degree of relevance, in a, again, natural way that will make sense to them. And with that said, let's take a look at what a RAG ingestion pipeline looks like. And again, we're gonna get into that specifically in our walkthrough. So we start with a data source, and that could be really anything, any sort of document base. Today we're going to walk through a Parquet file that has a bunch of data that was pulled from our own documentation website. Um, then we go through the process of chunking. So in order for us to be able to provide semantically coherent pieces of information that the LLM can build its response on, we need to take the original data and break it down into smaller pieces that the vector database can basically hone in on and then provide as a response to the LLM. So there's this chunking process and we're going to take a look at how that's done. Then we take each one of these, again, semantically coherent chunks, and embed those, use an embedding model to embed them, and produce the vector embeddings from those. And we're going to associate each of these embeddings with a piece of metadata that's going to help us down the line when we want to produce a response and basically give back some sort of indication as to where the response came from. Then using the Pinecone API, we upsert all of these into the vector database, and we can move on to the second half of the RAG pipeline, which is the application. So the RAG application itself works pretty much along very similar lines, where we take the user query from the application, we embed the user query, we use that embedding as our query to Pinecone. Through the API, we get back the results from the database. In those results, we have the metadata that was associated with the vector that we found to be most similar to the query vector that we sent in. We take those query results, we basically stuff them into the context of the LLM, meaning we pass them into the LLM together with the query that the user sent to us in the first place, and then we pass those results back from the LLM to the application. And that basically is the entirety of a RAG pipeline from ingestion to application. Now, there are three main considerations that I want to talk about today when it has to do with enterprise RAG. The first is scale. And by scale, I mean, there are many types of scenarios where scale kind of takes on a different meaning. It could mean that we have a massive amount of documents, and we have to sort of think about how we tackle those. And another sense of a scale could be that the level of interaction with our endpoint is high, meaning there are many users that are kind of wanting to ask our endpoint a lot of these questions, and it has to be very responsive. And of course, like those two have different kind of ramification in terms of the type of infrastructure that we need to have in place in order to satisfy those requirements. But that's like these are the core kind of situations where scale is something that we need to think about and consider when we build our pipeline. The second consideration is quality control, and by that I mean when we're in an enterprise scenario, we can't just trust that our RAG pipeline will do what it's supposed to do. We have to have some predictable measures that we can track over time to gain an understanding of what exactly is happening with our RAG pipeline and how each of the parameters that are affecting the pipeline itself are going to present in the final result. And for that purpose, I'm going to show one evaluation framework called RAGAS to basically give us an understanding of what would be the process by which um, uh, an enterprise organization may iterate around, moving around the knobs, right? Like shifting these knobs around to get better and better results over time. And we'll see that when we get to the code along portion of this talk. And the last thing is the DevOps consideration, and that is basically, this notion that these systems have to be resilient, they have to be built on good foundations, in the sense that when they do scale, when we do have a massive amount of interaction with them, they will continue operating as expected. And that immediately brings us to the realm of DevOps, making sure that like these systems run smoothly. I'm mentioning all of these three considerations because at the end of the talk, I'm going to present Pinecone Assistant, which is a solution from Pinecone that will help you achieve these three in a way that is incredibly easy and straightforward, without having to take all the steps to create all of them yourself. And with that, let's jump into our code. I can take maybe a couple of questions as we transition to code. Adele, is there anything that came up that we want to talk about?
So no questions so far, but I'll making sure to add those in the in our questions document. I'll make sure to ask those to you as they pop
Okay.
up. Don't forget, everyone, do ask Roy as many questions as you want. We'll make sure that we have time for questions at the end.
Okay. Great. So I think we're ready to start coding a little bit. So we're going to start with, the very basics. So like I said, today I'm going to read in a Parquet file. So a lot of the dependencies that you see here, like PyArrow and FastParquet, and even Pandas, are really just like helper dependencies that are mostly meant to help us read that data in. Marco is a dependency that will help us with markdown files, and I'll walk that later. OpenAI and Pinecone Client are obvious. Those are the two tools that we're going to use. Pinecone is our vector database, of course, and OpenAI will help us with embeddings and will serve as our LLM. RAGAS, as I mentioned before, is going to be our our mechanism for doing evaluation. I'm using the re-rankers library to do re-ranking, and we'll talk about re-ranking as we move along. Torch is, of course, like a general machine learning library that is used, I believe, by RAGAS as a dependency, but I had to manually install it for one reason or another. Okay, here we have just like very basic imports like the OS, pandas, and some display helper functions. And we start with just reading in some API keys, just so we can set them and forget them. So I'm just going to grab them from my document, my secrets documents over here on the side where nobody can see it. Of course, if you're running this on your own, you may choose to use .env and load these parameters from an env file. So if that's the case, you would just create an env file that looks like this, put in the keys, and you'll be good to go. The next step here is to basically read a set of data from again, really wherever you want. In our case, in this walkthrough, I'm reading data that was already sort of formatted to some extent. So we have here basically we can see this basically this Parquet file that was put into a Panda data frame. And in that data frame, we have like several columns. We have the ID column, a text column, which basically includes Markdown, which I'll show in a second, and some metadata that has the title and a date for when this thing was created, and a link to the specific source where the data comes from, the document where this text comes from. Now let's look at, I'll hide this. Let's look at what this text looks like. So as you can see here, I'm just like displaying a markdown of the text that lives within that data frame, within that particular cell. And it's just, again, just markdown data. There's nothing super special. When we get to the next step, which is chunking, we're going to start asking ourselves, in what ways can I break apart this data? And I would suggest that like the most obvious thing is to actually leverage the annotations that exist within the text itself. So as we'll see in a moment, there are many ways to chunk data, chunk text, and a lot of people ask that question of like, how should I chunk my text? I think that like more important than the specifics of the how, and we'll see that it's kind of an involved process in terms of like the code itself. What you want to ask yourself at this stage is, what are the semantically coherent units, right, that we're interested in, that if a user searches for, right, they would basically be happy to get as a result, right? And so in this case, we could leverage the fact that the text itself gives us some degree of definition as to what is a unit of text that is basically self-containing. For example, right here we see a single paragraph, right, that is separated by headers. As you'll see in a second, the Markdown chunker basically looks at exactly that. It looks at the structure of the Markdown file itself, and it builds out chunks based on that information. So let's look at this Markdown chunker. So of course you could choose to use Markdown chunkers that are already been built by LangChain, by other providers. Same goes with recursive Markdown chunker. Recursive chunker. I just wanted to build one here to basically demonstrate how straightforward it is, because there's nothing really magical going on within this realm of chunking. So basically, what we're doing is we're using Marco, which is the library I mentioned before, to parse through the Markdown text, and that gives us essentially elements within that file. And with that, we can basically look through and see if we're looking for each element that we're processing, if we're looking at a header or not a header, and if an element is a header, we can use it as sort of a separator. And if it's not a header, we can basically use the content of the text as the body of our chunk. And then we can basically take all of these chunks and combine them together, uniquify them, and send them back. So there's really nothing super complicated that's going on in here. It's a little laborious, but at the end of the day, we use the actual properties of, like I said, the headers specifically to guide us, to tell us how to navigate through the data itself to create those chunks. You could apply any kind of logic that you would wish to make this work in a different way. So if you want to handle, for example, code blocks in a different way, or any kind of other markdown property in a different way, you're obviously free to do so. And as I said, it's pretty straightforward to basically build your own chunker based on this. We'll skip recursive chunking for now for a little bit, and we'll see if time permits. We'll get back to it. But this is like yet another chunking methodology, which basically looks at the data and tries to build a chunk that is of a certain size, and it will continue adding tokens into that chunk until it gets to the max size, or close enough to the max size. But with that, let's just do this. And so here we basically initialize. Oh, did my kernel just die? I really hope not. Well, we'll find out very soon. Basically, in this cell, we're doing something very simple. We're initializing the OpenAI client we're initializing the Pinecone client, so that we can interact with them. We define our desired index name to create that index, and then we use the Pinecone client.listIndex method to basically check if the index name already exists in our database, and if not, the Pinecone client is going to create it. One thing that is worth noting, or maybe two things. One is the number of dimensions matches the number of dimensions produced by the OpenAI embedding model that we're going to use later. That's important. So we need to make sure that like the embedding model dimensions match the index embedding dimensions, and the model embedding dimensions have to match. We can use several clouds. We support AWS, but also Azure and GCP. So that is basically up to you. You can look up the serverless spec definitions to choose your own adventure there. Let's fire this up. And in my case, oh, there we go. This is indeed something died in here. Okay, I think we're good now. I'm hoping that our kernel is stable, and we'll find out very soon if not. So at this point, we expect there to basically be an index that has been created. Now, for the next couple of items here, I'll just say I've already gone through the process of creating the chunks, embedding them, and upserting them. And so I'll be able to run through the rest of this pretty quickly. And if you're running this for the first time, the process of creating the embeddings and upserting them may take between 5 to 7 to 8 minutes. And so you can still follow along with me if you'd like, or choose to run this afterwards. But I'll be continuing just for the sake of brevity here, and not to wait for the process to complete. Okay, so this function here, this embed and upsert, basically does two things, and exactly what it says, right? It takes a chunk of data, a chunk of text. It passes it to the text embedding Ada 2. Of course, you could use other models. Text embedding small is one that people have been using recently. Doesn't really matter for this particular scenario. But this is a knob that we have, so we can turn on this knob when we get to the evaluation portion of this exercise. And then we basically get back a response from the OpenAI client that will give us back an embedding. Then we take that embedding and we upsert it with some ID and the metadata that we are interested in using to Pinecone. So this is this function. Let's just look at how this is done here. Again, like I don't have to really run this because I've already done so. So basically, I'm going to iterate over the data, which is my initial Panda data frame. I'm going to iterate over each row. I'm going to take the text and run it through the markdown chunker. So now I have my text chunk. And then for each one of these chunks, I'm going to grab the metadata that's associated with that row, associated with that chunk. So like I have the created and the title for that particular chunk, and the ID of the row plus some index that's referencing the chunk. So each chunk is going to have a prefix that is relevant to the document from which it came, and a specific ID that is relevant to that chunk itself. And then the chunk text itself is going to be the chunk. I'm going to, again, add it to the metadata. So when I'm doing the RAG flow later on, I'll be able to reference it in my response and stuff that response into the LLM. And then basically after I do all of this, I append the chunk and the metadata to this array, and then run again over this array and run embed an upsert chunk with metadata. So yeah, and this is basically it. So at this point, I've completed the process of embedding and upserting. And let's just look at Pinecone for a second. So here I have my markdown chunks index. And in it, I'll just make this a little bit bigger. I have 1,521 chunks. And as you can see, I have the chunk text that includes the text itself for that chunk, the metadata, as I mentioned, and the chunk ID as a part of the metadata. Now, the retrieval portion of this is going to work, again, very similar, right? So again, we're going to use the same exact embedding model, and we have to do that, right? So we have to use the same embedding model on the query side as we do on the upserting, the embedding, the upserting side, to produce the same type of embeddings, so that the meaning of the text that we send into the model is mapped in the same way. And we basically run a query with that embedding against Pinecone to get the results. When we do that, we get a set of matches right here. So we have the results.matches. And for each match, we basically grab the metadata. We grab the metadata, and from that metadata, we grab the chunk text for that match. So I can just run this. And this is basically naive retrieval. So I'm not doing anything special in this retrieval step to improve the results in any way, right? I'm basically just specifying the number of chunks that I want to get back, which in this case is just 3, but I can override that when I'm calling the function, and I'm returning the chunks themselves. Later on, we're going to look at re-rankers, but right now, let's look at the actual end flow. So now we get to the point where we can actually create the augmentation portion of RAG, the A in RAG. And that basically means that we're going to pass, again, the question that we got from the user to the LLM alongside the context that we've created, right? That context essentially is going to be these chunks that we've collected here. And we'll see that in a second. So we pass in a prompt that basically says, given the following context, answer the following question. And then we give it a context, and we give it the question, and we pass that to our model. And of course, this is yet another place where we can start doing some work to without I don't mean to use this term literally, but to fine tune our system, basically to play around with these different knobs, right? So we can try to see what happens with when we use GPT-4, GPT-4o, GPT-4o Mini, or if we try to use like a completely different provider altogether. What happens when we do some different kind of prompting? We try and move this around. Maybe we put the query first, then the context second. Maybe we do some prompt engineering and make a better prompt here altogether. Here we have like a really very, very basic kind of level of interaction with the LLM, and we're expecting to see a result back. And this is the function basically that ties the application, quote unquote, flow all together. So we're asking the user for some inputs. We're going to retrieve the chunks based on the user inputs. So if we follow that again, if we go back to retrieve chunks, so again, we pass here the query. This will be the user's query. We do the embedding. We do the query against Pinecone, and we get back our chunks. And with these chunks, we basically call this context. We pass this context into augmented query with the user input again, the same query that we got, and the context, and we basically combine this context. We combine these chunks together with new lines, and finally we present the result. And so let's see what happens, and hoping that everything works together. And our query is going to be, how do you create an index in Pinecone using Python? Oh, there we go. We haven't defined augmented query. Let's run this again. Just copy this. There we go. And now we get the answer. It looks nice because it's in Markdown. We get the answer, some code snippet that actually looks correct. It's telling us giving us like an example index name, which is LangChain Retrieval Augmentation, which is interesting. Probably taken from one of our one of the documentation pages that talks about LangChain. Okay, so what if what comes next, right? So basically, we've gone through that whole process of creating the pipeline, and we saw that we have several places where we can sort of improve or play around with the system and kind of like change the way it behaves, right? So what are those places? One of those places is, again, the way that we do our chunking. So we could either choose to do markdown chunking or recursive chunking or semantic chunking, et cetera, et cetera, et cetera. So like that's one place. Another place is the embedding. So we can choose to use all sorts of embedding models, from off-the-shelf embedding models to smaller embedding models and bigger embedding models, and so on and so forth, through fine-tuned embedding models that are going to be specific to our specific needs. So for example, if we want to use an embedding model that has been tuned to legal documents, we could pick one up from say Voyage, this one provider that I know does this kind of work of creating embedding models that are fine-tuned on a specific type of content, and basically would perform better. We could play around with the type of model that we use for our LLM. That's another another knob that we can turn on. And these are basically like the main things that we can look at. And of course, like there's everything that happens upstream from us, right? It's like, what data have we added to the system? How have we added it to the system in the first place? That initial data set, of course, matters a great deal. Now, how can we tell whether or not all of these different modifications that we do to the system actually are significant and meaningful, and are actually helping anything in the process, right? How do we know that we're actually getting improved results over time? So for that matter, we do have to look into evaluating our pipeline. And to do this, we're going to use a framework called RAGAS. There are many ways to do evaluations. RAGAS has been around for quite a while. There is an open source library that is very easy to use, but it's definitely not the end all be all of evaluation. There are many more ways of doing it. I just want to make sure that that's mentioned. There are many providers that do this very well. Ones that come to mind are Galileo, among others. Other names are escaping me right now, but there are many others. So let's take a look at how this is done. So just for the purposes of RAGAS works on top of the document definition that comes out of LangChain, which has kind of been sort of codified. So we're just going to take our existing data that lives in our data frame and turn it into a set of documents that we'll be able to work with in this context. Nothing super special is going on here. We're just grabbing the text and the metadata from those initial documents, and we're turning them into the document specification from LangChain so that they can be used down the line. So what RAGAS basically does for us is it takes the documents themselves and it generates a set of questions based on that text. So that we can then basically evaluate and compare what is generated as the ground truth from our documents, right? And then compare that to what our RAG application does. So let's look at how this is done. So we basically pass in a couple of models, a generator LLM and a critique LLM, and the OpenAI embeddings as well. And what we get back from this test set, and very quickly, I believe it takes like just a minute or two, we're going to get back for every single document, we're going to get a question about that document, or a set of questions about that document that pertains to either a straightforward question, a reasoning question, or a multi-context question, meaning a question that spans over more than one document, right? And for each one of those questions, we're also going to get an answer that will serve as our ground truth, meaning we will be able to regard it as the real answer to the question that has been asked by the LLM, right? And down the line, when we run this test, we'll be able to see what is the difference between what our LLM has produced and those ground truth answers that were produced by RAGAS for each one of those questions that was created by RAGAS. I'm not entirely sure what's happening here. That's taking longer than anticipated. Let's see. We'll give it a second. Yeah, this usually takes a lot quicker. Is this still running? Oh, apparently it ran. Okay, perfect. Sorry, it already ran. Okay, so here it is. So here we have questions like the questions are here on the left. The ground truth is right here. So the process that Ragus goes through is, again, like very similar to the one that we had before. It basically builds a context for to produce that question, to produce the answer after the question has been created, and then it produces the answer based on that context. And we'll see in a moment how that comes into play when we generate our test results. As you can see here, here's where we basically generate our test result, and after that, we basically generate the actual metrics by which the whole system is going to be evaluated over, and we'll go over some of them in a moment to see what they exactly mean. Just a moment. Okay, so this was completed. Okay, so here what we have is not only the question, we have now another column called answer. And as you can see here, the answer in this case was created by our augmented query function, meaning it is no longer the Ragus framework providing this. This is us providing the answer, right? The ground truth is the ground truth that was created by Ragus, and the answer has been provided by us, right? And so now we can take this data set that was created, this test result data set, and we can run it through this evaluation, and we'll print that in a minute. And here we're going to basically check for a bunch of different metrics, all right? Some of them are things like faithfulness and answer relevancy, correctness, similarity, context recall, precision, etc. Each one of them kind of looking at a different aspect of the quality of the answer, right? So things like answer correctness are obvious, right? Basically, is this answer correct or not? So we can see, like in this data set, right, and we got about 56% correct, right, which is quite low, right? So we can ask ourselves, what pieces of the pipeline can we now change to make this a lot better? So for example, I'll just do this very quickly, because this is exactly the process that you would have to go through if you were to try and improve the results coming from your system. I'm going to change augmented query to use GPT-4o. Okay, and I'm going to call this again. Call this generate test results again, and see what the difference is. Right, so like this is this is essentially the process by which we look at the results as they come back from our test set, and then ask ourselves, like, what knob can we turn to actually improve the result, do that modification, and then compare the outcome with a previous run, essentially. While that's running, we have about 4 minutes before we start taking questions. I just wanted to go over one last thing, which is Pinecone Assistant. So as you saw before, and I'm not going to run through this code, I'll let y'all do this on your own time. Once you have Pinecone, you can basically use the Pinecone Assistant, which gives you all of this served on a silver platter, so to speak, right? So essentially, this is all of this entire pipeline is all contained within the Pinecone Assistant, and lets you worry about only the things that you really need to worry about, which is the quality of your data coming in. All the rest is basically on Pinecone to produce the best possible result that we could possibly produce, given your data. The way that you interact with this is kind of similar in some ways to the way that you interact with this with an assistant. So you basically you can create an assistant programmatically and associate it with whatever metadata you want. You then take a set of files. Right now, we currently support text files and PDF files. You iterate over them, and sorry, this is not it. Here, we iterate over the files over here, and we basically upload them to the assistant. And once that's done, our work here is basically done. We don't have to worry about chunking. We don't have to worry about embeddings or upserting or any of that stuff. We just have to upload the files. And once we completed that, we get a OpenAI compliant chat completion endpoint that includes streaming support as well, that lets us interact with that endpoint as we would otherwise with any other chat completion endpoint. The reason I'm mentioning this is, again, to tie back to the beginning of the talk. All of the considerations for an enterprise solution, which includes scale, scale, what did I have there? Sorry, I'm blanking on it. Quality control and DevOps considerations are all taken care of, meaning I don't have to worry about what happens when this endpoint gets hit with 1 million users. I don't have to worry about what happens when I have 1 billion documents in my assistant. This is what Pinecone was built for, and this is what it's good at doing. And to just finish up, I believe that we might have already completed this run. So let me just run this evaluation one more time. And still running, and now it's done. No, I'm just going to add another column here, another cell here, sorry. And I'll just run this after, and we'll be able to compare the results. Yeah, in the meantime, we can start taking questions.
Okay, that was awesome, Roy. We have a few questions already from the audience. I'll let them add as well, because I have a couple of questions as well. And that's actually something I've been curious about quite a lot, which is, what's the difference between RAG and fine-tuning, and how should we be thinking about kind of the trade-offs between both techniques? When do you use one versus the other?
Yeah, that's an excellent question. I just want to point out one thing before we answer that. So just changing the model here from GPT 3.5 to GPT 4.0 got us some different results here. So just to look at answer correctness, we got closer to 0.59 as opposed to 0.56 before. On the other hand, we lost context precision, our faithfulness sort of went down, and answer relevancy also went down, and so on and so forth. So like you can basically see like there are a lot of trade-offs between playing around with different models. Like that would be like a way to look at that. And just to close this loop completely, again, this is just one of the knobs that you have to play around with. And this may like kind of connect well with this question, right? Of what's the difference between RAG and fine tuning? So RAG is a process which basically says we're moving like the responsibility for providing the ground truth, right, away from the model and onto a different paradigm altogether, basically. And that is a database, right? Like it could be a vector database. It could also be a graph database. It could be a SQL database, etc. That basically means that the way that you would get sort of the quote unquote the justification for why a response is correct, right, in a completely different way, right? So when you're doing fine tuning, first and foremost, like the way you go about it is, it requires that you have the data set that would be sufficient to produce that improved result, right? To basically, again, fine tune your model. Um, it requires that you have compute sufficient, right? Like so, like to actually do the training. So
Mm-hmm.
you're going to have to pay with a lot of GPU, and what you're going to end up with is yet another LLM, right? That has been improved in its capability to answer a set of questions or to interact in a domain that is specific to the material that you focused in, right? It's not going to fundamentally change the way that this LLM operates, right? It's still
Yeah.
going to be an LLM, right? So it's still going to predict the next token, and that's basically it. Whereas RAG changes the equation completely, and again focuses the responsibility of retrieval of on again on a database, right? That changes the balance of power, so to speak, right, between the things that you can know and the things that you can't know, right? So even in a fine tuning situation, you will never know why an LLM chose to answer the way that it did, right? It's just like a limitation that we currently have with LLMs, right? Maybe that will be solved in the future, but that's the current limitation. With RAG, you again shift that responsibility to where you can trace the reasoning, right, for why an answer was given in the way that it did, right? Because it's because it's based on content that you have control over. So at the end of the day, it's all a question of control, right? Where's the
Mm-hmm.
control? Where does the control reside? Is it with the user, with the developer, with the database, or is it with the LLM and the person who trained the LLM?
Okay, that's awesome. And then maybe an additional question as well, as we're taking more questions from the audience, is when you think about, we talked about RAG versus fine tuning, but then there's an additional component. A lot of folks want to deploy these applications into production. Maybe what are the nuances or particular challenges of setting up a RAG pipeline in production rather than, on a notebook here?
Yeah, for sure. So like I mentioned in the talk, like scale is definitely like the biggest nuance, right? So um, it ends up being that the ingestion process is usually fairly heavy, like relatively speaking, because again you're tapping into a model, right? And that usually calls for either some sort of, I mean, again, and it depends on the situation.
Mm-hmm.
It may call for some distributed computing solution, or it may require another type of kind of like high touch, like high, basically, it's like maybe like a stream um, of data that comes into like a pipeline that kind of like processes through that data on a very high speed kind of uh, uh, profile. Um, and in those situations, right, like that's like the biggest bottleneck, right? Like is how do you ingest the files in time, and how do you update your index on time, right, such that when new data is being made available, like it takes the least amount of time for it to sort of be reflected in your application, right? That's like on the one hand. On the other hand is the consumption level, right?
Mm-hmm.
The biggest hurdle there is, again, like if I have like a million users, right? Like how do I make sure that the performance that each of them gets is ideal, right? And again, in that scenario, right, like the more that you rely on, let's just say the less that you rely on an LLM to be your um, uh, source of truth, of ground truth, the faster your application is going to be, because basically when you say like, hey, I can actually rely on my database to be like my source of truth, then and the LLM basically plays that role of just like a natural language
Yeah.
interface, then it could be a smaller model, it could be a faster model that actually does that work. You don't have to call into the biggest, most sophisticated models to do that work, right? Because you can
Okay.
basically trust that that knowledge has already been done.
Okay, brilliant. And I think now I'm going to start taking some audience questions. So, first one from Vivian. How can we prevent duplicate records inside of the Pinecone index from, for example, accidentally inserting the same data more than once? So, Riley, you cover that.
Yeah, that's a good question. In theory, there's not a real way to prevent it completely. It has to be done upstream.
Mm-hmm.
You could, in theory, basically query for vectors that exist in Pinecone. Um, and if you get a vector that has, that basically has 100% similarity, meaning it's the same vector, not inserted, in our case, like it's not as consequential because vectors that are completely identical will just merge, right? Unless
Mm-hmm.
you give them a completely separate ID.
Mm-hmm.
Um, and so like you would get back the same result twice, but it wouldn't necessarily matter. Um, the the other way is again just like querying to see if you already have a piece of text, if you already have a piece of information in Pinecone that you don't want to upsert, and then just not upserting it. That would be
Okay.
my best piece of advice there.
Okay. Awesome. And then another question here from um, Anandaraj. I hope I'm pronouncing your name correctly. Are we able to integrate Pinecone with Olama?
Um, so as far as I know, Olama is basically just a way to run large language models locally. Um, you could do that. I mean, the point is that, like, once you have Olama running on your machine, you can call into Olama using, I'm pretty sure, an API, and then run, against Pinecone with an API as well. So like you would basically write a program that calls into your model and then calls into Pinecone. So Pinecone doesn't really care about
Hmm.
like what model you're using, right? So it could be an Olama locally, or it could be something else, right? Doesn't really matter.
Okay. Perfect. Another question here. Uh, Another also from Vivian. What happens to the LLM response when there's a lack of context, actually no information for the Pinecone index in a RAG design?
That's a really good question. So that really depends on the prompt that you give it. So
Mm-hmm.
a lot of the time, what I would do is say to the LLM, if the context is empty, say I don't know. Right? That's really one of those things that differentiates RAG from anything else. So like an LLM will give you an answer no matter what. A RAG situation, right? Like that you have the opportunity to decide what you're going to do given different situation of the context. So you could either say, you can either basically check, right, to see if there's
Mm-hmm.
something in the context versus not. You could either tell the LLM to make that decision on its own, or you could programmatically say, if the context is empty, just return I don't know, or I can't answer that question, which
Mm-hmm.
is incredibly important in cases where there's actually a user asks a question that like the company doesn't want to answer or can't answer, or there is no knowledge in the knowledge base to answer.
Okay, that's really great. Maybe final question from Govinda. How will Pinecone take care of chunking and embedding? Can I also tune it if needed? Can I tune, the
So
chunking and
if
embedding parameters?
so if I'm understanding correctly, this might be about Pinecone Assistant. Um,
Mm-hmm.
so Pinecone Assistant will take care of chunking and embedding, and you don't have to care. At the moment, we don't allow for any kind of fine tuning, essentially, right? So basically, configuration of the chunking and embedding in Assistant. And if you do want to do that, that's where you basically sort of build your own and kind of like build your own pipeline, if that makes sense.
Okay. Awesome. I think this wraps up questions from the audience. There's one extra question on incremental data load. Maybe I'll ask that one as well, because how will Pinecone handle incremental data load? So if you add, after training your model, after building your RAG system, add incremental data, how will that, be managed?
Yeah, I mean, again, Pinecone is kind of like agnostic of how you add your data. So
Mm-hmm.
you can make the decision to add it in whatever manner you want, right? Like the question is like, what are the performance characteristics that you're looking for? Um, Pinecone knows how to deal with massive amounts of data, and to make sure
Mm-hmm.
that the index is um, uh, basically up to date and available in a very short amount of time, right? So when you're dealing with incremental data loads, it's very likely that you do the load, and up to minutes later, the data will be available on the other side.
Okay. Awesome. I think this wraps up today's code along. I want to say a huge thank you to Roy. for joining us today, for showing us all the great things you can do with Pinecone. I want to say a huge thank you for all of our attendees today, everyone who joined in from across the world. It really means a lot to us. And with that, I'll let everyone be. Have a great day.